Hello there, welcome to CXC Math TV. Today we're going to be doing summation questions using past papers. So this is taken from the June 2008 paper, and it says show that the sum from r equal 1 to n of r times r plus 1 is 1 over 3n times n plus 1 times n plus 2. Then hence or otherwise evaluate the sum from r equal 31 to 50 of r times r plus 1. So let's go ahead and begin. So first thing we have is the sum from r equal 1 to n of r times r plus 1. Alright, the first thing you're going to do is expand in the bracket. This can become the sum from r equal 1 to n of r times r is r squared plus r times 1 is r. So that's what we have now. Then we know by laws of summation we can break this up as the sum from r equal 1 to n of r squared plus the sum from r equal 1 to n of r. Wow! All you have to do now is remember this formula. The sum from 1 to n of r squared, that's on the formula sheet. That is then given by 1 over 6n in bracket n plus 1 times 2n plus 1. That's the formula for it. And then we need to remember what's the formula for the sum from 1 to n of r. In blue, if we write it, that formula is a half n in bracket n plus 1. We just need to remember that. So now we need to go ahead and add these now. But to add these, look what I'm going to do. Do you see that this half right here? I'm going to rewrite a half. Look what I'm doing here. I'm going to rewrite this half as 3 over 6. Can't I do that? Absolutely. Now, if you were to observe as well, they have n in common and n plus 1 in common, right? So I notice that I can factor out 1 over 6, and I would be left back with just 2n plus 1 on this side. And over here, I would left back with the 3, just 3, right? Oh, my apologies. I left off the fact that I factored out n times n plus 1. Alright, so right here I factored out 1 over 6n times n plus 1. Alright, I factored out 1 over 6n times n plus 1. And so now I am left back with right here 2n plus 1. And then right here I'm left back with plus 3. So when I simplify, this is just 1 over 6n times n plus 1 times 2n plus 4. Now, if you were to observe, you see this number 2n plus 4. Can't we factor out a 2 from that? We can rewrite this now as 1 over 6n times n plus 1 times, you see this 2n plus 4? We can write it as 2 times n plus 2. Now remember that multiplication is what? Commutative. So this 2 right here, we can bring it all the way over to be 1 over 6 times 2 times n plus 1 times n plus 2. Alright, I put a dot to represent the times. This dot represents time. All I do was move the 2 from here, come over here, because multiplication is commutative. In the same way, you can write 2 times 5. In the same way, you can write 2 times 5 times 3. Or we can say this is 2 times 3 times 5. We can move the 3 here. It's the same way. All I do is move the 2 from right here. I move the 2 from here and put it over here. When you're multiplying, we know multiplication is commutative and associative. Alright? So what we're then saying then is when we multiply this, we see that the 1 over 6 times 2, 2 into itself 1 time, 2 into 6 3 times. So it works out to be 1 over 3n times n plus 1 times n plus 2. Wow! So therefore we can conclude that the sum from 1 to n of r times r plus 1 is indeed this formula. So prove it. Prove it. Alright? So the sum, so we can tell them the sum from r equal 1 to n of r times r plus 1 is indeed this formula. Nice. So now we need to do the second part. It says hence or otherwise evaluate the sum from 31 to 50. It says hence or otherwise. So look at this now. So the sum, this is part 2 now. So the sum from 31 to 50 of r times r plus 1. Now guys, look at this. The formula gives us from 1 to n, right? We can only use it if we're summing from 1 to n. So look how we're going to do this now. Can't we sum from r equal 1 to 30? Not 30, 1 to 50. My apologies. Can't we sum from r equal 1 to 50 of r times r plus 1 and then subtract the sum from r equal 1 to 30? Think about it. Makes sense, right? What we're saying is if you're adding up from 31 to 50, you can add from 1 to 50 and then subtract from 1 to 30, right? Just to write it down in another sense, look at this. If you're adding up numbers 1, 2, all the way up to 10, right? And you wanted to add from 6 to 10, right? We're saying that in order to add from 6 to 10, I'm actually going to give you an example here. Let me write it out so you can follow what I'm saying. I want us to follow exactly what I'm saying. Look at this. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10, right? Let's say you wanted to just add up 6 plus 7 plus 8 plus 9 plus 10. Let's say you wanted to add up that, right? Can't we say that adding from 6 to 10 is the same as adding from 1 to 10? It's the same as adding from 1 to 10 and then subtract when we add from 1 to 5. If you don't believe it, look at it. 6 plus 7 is 13 and 8 is 21 and 9 is 30 and 10 is 40, right? Did I add that correctly? Should be. If you were to add from 1 to 10, look at it. 3, 6, 10, 15, 21. 21 and 7, 28, 36, 45, 55. So from 1 to 10 is 55 minus, adding from 1 to 5 now. 3, 6, 10, 15. 55 minus 15 is what? 40. Wow. So notice adding from 6 to 10, we could add the whole thing and then subtract adding from 1 to 5. In other words, we're saying in the same way to find the sum from 1, to find the sum from 31 to 50, we can now say it's the sum from 1 to 50 minus the sum from 1 to 30. That's all we're saying, right? So since that's all we're saying, in order to use this formula, so the sum from 1 to 50 minus the sum from 1 to 30. Why did we do that? We do that so now we can apply the formula above. Because we just learned a formula above that tell us that the sum from 1 to n of r times r plus 1 is this. So we can replace n with 50 here to evaluate this side. And then replace n with 30 to evaluate this side. Take the difference and that will give us the answer. Wow! So let's go ahead and do that. So now we can get that this is now equal to the sum from 1 to 50 would be 1 over 3 times 50 times 50 plus 1 is 51 times 50 plus 2 is 52. Then we're subtracting 1 over 3 times, replace n with 30, that's 30 times 31 times 32. That's what we have. So then we just need to simplify this. This is going to be factor out 1 over 3 and we have 50 times 51 times 52 minus 30 times 31 times 32. Now I'm just going to put this in my calculator because that's a pretty big number, right? That's pretty big. So 1 over 3 times in bracket 50 times 51 times 52, and then I am subtracting, oops, it slipped out of my hand there, 1 over 3 in bracket 50 times 51 times 52 minus 30 times, minus, let me put a bracket there, 30 times 31 times 32. Close that. And we get 34,280. So the final answer is 34,280. Alright? So that's what we're supposed to get. So we can tell them this is 34,280. Wow! And that's how you do this summation question right here. Really nice. Alright, so now this question is taken from June 2010. And I want you to pause the video and attempt this question. It says, use the fact that Sn, which is the sum from 1 to n of r, is equal to a half n times n plus 1. I know this is a little scribbly, but all that is saying is that the sum, let's write it down. It's saying that Sn is the sum from 1 to n of r. It is a half n times n plus 1. Use that to find S2n and then find the constants P and Q. So pause the video and attempt this question. Alright, so as you pause the video and attempt this question, the first thing we'll notice is to find S2n, replace n with 2n. So let n be equal to 2n. So S2n is then the sum from r equal 1 to 2n of r, which is a half, replace n with 2n, and then replace this n with 2n. That's what we have. So this is going to simplify to be 2n over 2, which is n. 2n over 2, look what I'm saying. This 2 cancel this 2, right? So we have this 2 cancel this 2, leave n, and we have n times 2n plus 1. So that's the expression for S2n. In other words, we can say S2n is equal to n times 2n plus 1. That's it. Now the next part says find the constants P and Q such that S2n minus Sn is Pn squared plus Qn. So to do that, we say S2n minus Sn, that's equal to S2n we just found is n times 2n plus 1. And then we subtract Sn, and Sn is, where is Sn again? They told us Sn is a half n times n plus 1. So this is what we have, right? So we just need to simplify this expression. This becomes 2n squared plus n minus a half n squared minus a half n. 2n squared minus a half n squared, that is 3 over 2n squared. And then n minus a half n, that is just plus a half n. And if you're equating this to Pn squared plus Qn, in other words, we're saying that P is equal to 3 over 2 and Q is equal to a half. Wow! That's your answer. P is 3 over 2 and Q is equal to a half. So P equal 3 over 2, Q equal a half. That's really nice, right? That's lovely. Alright, now the next part of the question says, hence or otherwise find n such that S2n minus Sn is 260. Nice. So we need to solve S2n minus Sn equal 260. In other words, S2n minus Sn, we just found that that is this expression right here, right? So that is going to become 3 over 2. So that is, let's go around here. That is now 3 over 2 n squared minus, well, it was a plus actually, plus a half n, and this is equal to 260. And we need to solve this equation for n. So first thing we can do is multiply through the equation by 2 to get 3n squared plus n is equal to 520. That becomes 3n squared plus n minus 520 is equal to 0. Now we can then proceed to factorize. So that looks difficult for me to factorize. So I'm just going to use quadratic formula. It looks difficult for me to factorize right away. So I'm going to say n is equal to, using quadratic formula, it's minus b plus or minus the square root of b squared minus 4 times a times c divided by 2a, which is 2 times 3. In other words, I'm getting n equal to, let's put it in our calculator. So that is minus 1 plus the square root of 1 square minus 4 times 3 times minus 520, that divided by 2 times 3, and this is working out to be 13. So n equals 13. Or, look at this now, or the next value is when you have the minus. When you have the minus here now, so change a plus to a minus. When this is a minus, what happened? When that is a minus, we get negative 40 over 3. Or n equal negative 40 over 3. But guess what? This can't make any sense. This part is not valid. This part not valid, right? This part not valid. Because n can't be a negative number. And n also has to be whole. So the final answer is n is equal to 13. Alright, so what we're saying is when n is 13, S2n minus Sn is 260. Alright, that's all we're saying. That's literally all we're saying. When n is 13, that's when the sum is going to be equal to 260. Now, alright, so this is another summation question right here. So I want you to pause the video and attempt this question. Evaluate the sum from r equal 1 to 99 of log base 10 of r over r plus 1. Pause the video and attempt. Right, so now we're going to attempt this question right here. So notice this is not your typical logs question, right? So we need to evaluate the sum from r equal 1 to 99 of log base 10 of r over r plus 1. So the first thing we're going to do is input r as 1. That's going to become 1 over 1 plus 1 is 2, right? But then we need the log of it. So let's put our log in front. So this is now the log base 10 of a half plus, we then put r as 2 to get log base 10 of 2 over 3 plus, we then put r as 3 to get log base 10 of 3 over 4 plus, we keep on doing that until we input r as 99, and that will come 99 over 99 plus 1 is 100. But then using laws of logarithm, what do we know? Using laws of logarithm, we can then rewrite this as log base 10 of, remember this is law of logarithm, log a plus log b is equal to the log of a times b. So that's going to become a half times 2/3 times 3/4 times 4/5 times all the way up to 99 over 100. Now this is what I want you to observe now. Look at this. This 2 cancel this 2. This 3 cancel this 3. This 4 cancel this 4. This 5 cancel this 5. All the way up to this 99. This 99 would cancel this 99. So it's actually working out to just be log base 10 of 1 over 100. Now log base 10 of 1 over 100 is log base 10 of 1 over 100 is actually just 10 to the minus 2. Because remember, this is 100 is 10 square, right? So that's just 1 over 10 square. And 1 over 10 square is 10 to the minus 2. So we're saying this is log base 10 of 10 to the minus 2, which will work out to be minus 2 log base 10 of 10, if we remember laws of logarithm. But then log base 10 of 10, we know that is 1. So the final answer is negative 2. Wow! All of that works out to be negative 2. So not your typical summation question, but still fairly nice, right? And you can always test your answer with your calculator. All right, test it with your calculator, but that's how you'd get your -2.